Good day, everyone. This is your Aunty T in another class section. Previous class, we look at careers in chemistry and we look at the physical changes and the chemical changes. But today, I hope you are with your notes. Always be with your notes so that you can as well jot something meaningful down as well today. So today we are looking at another interesting topic, which is particulate nature of matter. Another that's looking at the building blocks of matter, what's made of matter. And before proceeding, I remember the first class we talked about the definition of matter as anything that has mass and occupy space. Anything that has weight and occupies space, that is the definition of matter. But today let's look at the building blocks of matter. This matter we're talking about, I remember I told you guys, everything in the universe, they are made up of matter. And then, let's look at the building block. We have three building blocks of matter. The first one is atom. Number two, we have the molecule. And the third one, the atoms, the molecule, we have the ions. The ions, the atoms, molecules, and ions, they are the building block of matter. So if anybody asks you, what are the building blocks of matter? I tell them atom, molecules, and ions. And we now look at atom. Let's look at atom. Atom. According to John Dalton said atom is the smallest indivisible particle of an element. The smallest indivisible particle of an element. Of an element. But according to Millikan, the ghosting, and they proved the definition of John Dalton wrong. They said no, this atom we are looking at still consists of another three fundamental sub-particles, which they called the neutron, the proton, and electron. The first one is the neutron. The neutron. Number two, the proton. And number three, we have the electron. So the neutron, the proton, and electron. Neutron is said to be positively charged. No, I mean the proton. The neutron is said to be neutral. It doesn't have any charge. While the proton is positively charged and the electron is known to be negatively charged. So we have another subparticles of atom, the neutron, the proton, and the electron. So we now look at, there's another thing which we call energy level. We call it energy level. Energy level. So this energy level, there's another energy level we call them the K, the L, M, and O. Energy level diagram. We call them sub-level diagram, sub-level. But each one of these alphabets, we can represent our K. In our K, our N will be equals to 1. In L, its N will be 2. For L, our N equals to 2. For N, our N equals to 3. For N, our N equals to 4. While for O, our N equals to what? 5. This is for K. In K, N equals to 1. L, N equals to 2. M, N equals to 3. N equals to 4. And O, N equals to 5. But for us to know the actual amount each energy level can accommodate, there's a formula that we use. That formula is 2n squared. So this is the formula to know the actual electron that K sublevel can accommodate. So let's do it together. Let's work it, just a simple mathematics. Let's work it together. Remember, we want to know the actual amount of electron that K can occupy. So remember, our K is 1, when N is 1, that will be 2 into bracket 1 square. And this one will give us what? That equals what? 2. 1 square is 1 times 1 is also what? Is also 1. That is 2 times 1 give us 2. So that means our K can contain maximum of 2 electrons. So K can contain maximum of 2 what? Of 2 electrons on its orbital, on its shared energy level. So let's work that off. Hell, the next one is hell. Hell, that is when our K, that is 2 into bracket 2. Remember, our hell is 2. 2 square. So that will be 2. 2 square is what? That is 4. 2 times 4. That will give us what? 8. So our hell can contain the maximum number of what? Of 8 electrons on the energy level diagram for hell. Let's move to the hand. So let's look at our hand. For hand, remember our hand, n equals 3. So that will give us what? 2 into bracket 3 square. That is what? 2. 3 square. 3 raised to power 2 is what? 3 times 3, which is 9. 3 multiplied by 9, which is equal to 18. So our hand can contain what? 18. Maximum number of 18 electrons. So our N can consist of the maximum number of what? Of 18 electrons. The next one is our hand. In hand, n equals 4 in hand. So that was 2 into bracket 4 square. So 4 raised to power 2, that is 4 square, that is 4 times 4 is 16. That will now be 2 multiplied by 16, which gives us what? 32. So N can contain maximum number of what? Of 32 electrons on its shell. And the last one is the hole. Remember, in hole, our N equals 5. That will be 2 into bracket 5 raised to power 2, 5 squared. So that will give us 5 raised to power 2 is 25. So that is 2 multiplied by 25. So that is 50. So that means O can contain the maximum number of what? Of 50 electrons. Are we together? So if anybody asks you, maybe your objective question, in chemistry question, they ask you, what is the maximum number that K can accommodate? This maximum number of electrons that K can accommodate is what? Is 2. If they ask you, what is the maximum number of electrons that N can accommodate in the shell? Is 8. If they ask you, what's the maximum number of the one that N can accommodate? You tell them is what? Is 18. And the one that N can accommodate is what? Is 32. Whereby the one that O can accommodate is what? Is 50. So let me now show you how you should show the shell diagram. You can see this diagram. The diagram. So the diagram goes like that, like a circle. The diagram is a circle shape. So we turn this one, this is our K, followed by our L, followed by M, followed by N, and let's have the last one. I hope it doesn't tamper with this, sorry. We have to tamper with this a little. Let's have our 18 here. So, I said, this is our hole. This is our hole. So, we continue again in the next class with a lot of little calculation on this energy level. And I hope you enjoyed today's class. I promise you that the next class will be enjoyable as well. I love you all. Thank you for watching. God bless you. Remember to subscribe. I love you. Thank you.